Hello again. So today we're going to go through a complex, unfamiliar question, which is on the QCAA External Assessment 2021, Paper 2. So this is complex numbers. So Unit 3, complex numbers 2. So using this question's solving for roots of polynomial. So we have the given P polynomial function, Pz is the cubic. So missing A, B, C. But we know, so there's two conditions we're given. The first one is the Pz is Z equal to 2 is the root, number one. The other two roots are the also roots of this polynomial. So we're given a little hint to use. So let's determine the possible expression for Pz, which is, so that basically we need to know what is A, what is B, what is C. All right, so let's using the roots, the theory of the roots. So first condition, we know, so Z, so let's using Z equal to 2 is the root of Pz. So therefore, so P using 2 to substitute to Z, so B equal to 0. Also given us is means Pz, we can write into Z minus 2, then bracket times by another quadratic. So we must say quadratic is Z plus 2, Z to the square plus mz plus n. So we don't know what. So now we're going to decide the next quadratic roots. So we're assuming, so we're going to say quadratic. So there's now we know if I call this Qz is Z plus mz plus n. So we are say there's two roots. We're assuming there will be Z minus Z1 and Z minus Z2. So we know because of, we might say because of Z1 and Z2 is are also the roots of Z to the power 4 plus Z to the power 3. So because this is the condition given from the question. So now we're going to decide what is the roots of this particular function. So we say, according to the given condition, Z to the power 5 minus 1 equal to Z minus 1, Z to the power 4 all right, so therefore, if I'm going to switch this one, must be equal to z to the power 5 minus 1 divided by z minus 1. Okay, we're going to solve for this. So if we can let it equal to 0, so therefore z to the power 5 minus 1 equal to 0. So let's solve for this equation. So therefore z to the power 5 equal to 1. So now we're going to use the De Moivre's. So z to the power of 1 means if I'm using De Moivre's, say it's, so we call, let's say z is CR, CRS, theta. So if I'm using that, so therefore z to the power of 5 will be 5 r to the power of 5 cis 5 theta. Now because it's equal to 1, so therefore the magnitude of so R5 must be equal to 1. So therefore the R should be, so the magnitude of complex number is 1. So therefore the Z should be, so if I'm using the Z, so therefore should be Z equal to cis 5 theta. So equal to 1. So that means this. So we're going to solve for theta. So if we want to find out what's Z, we're going to solve for theta. So therefore 5 theta must be equal to 2k pi, because cosine theta equal 5 theta equal to 1 cosine. So remember, this is means cosine 5 theta plus I sine 5 theta equal to 1. So we're going to solve for the real components, for the real part of, so therefore 5 equal to 2k pi, so theta will be 2k pi divided by 5. K is a integer. So therefore, we got Z equal to, we can write into a cis form. So 2k pi over 5. So k is integer. So are we're going to use, so because of this function has two roots with the same function of has the same function of same roots of this quadratic. So we're going to say, let's say we have we say assume, because this is a z to the power 4. So that means if I'm assuming z, there's a one pair. So let's assuming a pair of the roots must be a the two conjugate roots. So therefore, we will say we call Z1 equal to R cis. Let's using K equal to 1. So we say let's assuming these two are the roots of those two conjugate. One is a positive, one is a negative. So we call K equal to 1. So this is a conjugate pair. So now we say, okay, we're going to substitute. So therefore, I'm going to put into the PZ. So the PZ, we can write it into first Z minus 2, which is already given. The next one will be Z minus Z1. I'll call this 2 pi divided by 5. Then the next one, Z minus the conjugate. So remember, always there's a pair. Conjugate is the two roots. So we say my polynomial is written in 3 brackets. And that's not our answer because the answer has to be expanded form. If you look at the question, it says you need an expanded form. So let's expanding that. So Z minus 2, we're going to expanding the second and third brackets. So those 2 brackets I'm expanding first. So next one's Z square, then CIS negative Z plus then minus CIS positive 2 pi over 5 Z and plus CIS 2 pi over 5 times by CIS negative 2 pi over 5. That's my expanding the bracket, second and third. So keep going. I'm going to leave this one for a moment. I'm going to expanding. So let me collect those 2 like terms. So these are the like terms I'm going to put together. So I'm going to put a Z square bracket minus CIS. I'm going to put 2 pi over 5 in the front plus CIS negative 2 pi over 5 on the end and put a Z. So that's the, collect those 2. And these 2 together, we know is a CIS 2 pi plus 5 minus 2 pi, which is 0. So that's basically this is 1. All right, cosine 0 is 1, then sine 0 is 0. So that's 1. So now we're going to simplify this because that's a very long thing. We're going to simplify. So let's do that separately. So I'm going to put a CIS 2 pi divided 2 pi divided by 5 CIS negative 2 pi divided by 5. I'm going to do a simplification. I'm going to write it into cosine 2 pi over 5 and plus so I sine 2 pi over 5 plus cosine negative 2 pi over 5 plus sine negative 2 pi over 5 I. So maybe put I in the front. All right, so keep going. So these 2, can you see cosine theta? That's a negative cosine theta we can put in. So because that's a positive, because we know cosine negative theta is positive cosine theta. So therefore, those 2 are together, become 2 cosine positive 2 pi over 5. So those 2 collected. And these 2, we know sine negative theta is negative sine theta. So those 2 are cancelled. So therefore, this guy here is only 1 term left. All right, so now we go to PZ. Simplify to Z minus 2 z square, and this guy just 2 cosine 2 pi over 5 z plus 1, because that's a 1. All right, now we're almost there. We're still not quite, because we need expanding more brackets, because we need expanded form. We need ABC, so we're going to expanding that. So let's do the order 1, 2, 3. Okay, let's do that. Z to the power 3 minus 2 cosine 2 pi over 5 z square plus z negative 2z square plus 4 cosine 2 pi over 5 z and minus 2. So I'm going to collect the lower terms. Z to the power 3 first, and then those two together. So we can put in 2 negative 2 cosine. I wanted to put a 2 outside. Cosine 2 pi over 5 plus 1 z square. Then plus those two together. I'm going to using let's change to green color. All right, so now we're going to use the next one. Okay, we're going to use the, sorry, we're going to use, collect those two together, this with this. So be 4 cosine 2 pi 5 plus 1 z, then the last one was 2. So now we find that's my pz. So my a is this. B is 4 cosine 2 pi divided by 5 plus 1, then C is negative 2. That's it. That's the expanded form. So we find the ABC. This is a little bit tricky, because when we simplify the cis form, we need to know how do we. Also, there's the conjugates is the theory we are. So if I have one roots, the other roots must be as well. The second was negative. So it's a pair. All right, so that's the complex unfamiliar question 18. If you like the video, give us thumbs up, and also don't forget subscribe to the channel. I'll see you next time. Thank you for watching.